This is section 6.1, part 2, so the back side of your fillable notes or the second page. We're still looking at interior angles. We now have a regular polygon. We know that a regular polygon is a polygon that has equal sides and equal angles. This regular polygon has interior angles of 135 degrees. That means every angle of the polygon is 135 degrees. It asks us to find the number of sides of the polygon. Find the number of sides of the polygon. Well, what I do know is that 135 times the number of sides is going to be the sum of all of my angles. I also know that the sum of all the angles is n minus 2 times 180. So I've substituted and made a connection here. I've balanced both sides of my equation and said that the sum of all the angles is 135 times n, and n minus 2 is times 180. So if I distribute this out, I get 180 times n minus 360. All of that is equal to 135 n. I will subtract 135n from both sides, and I will add 360 to both sides. That leaves me a positive 360 degrees on this side and 45 times n degrees on that side. Divide both sides by 45, and I come up with n of 8 sides. Find the number of sides of the polygon. The next question asks us to do essentially the same thing. It says I have a regular polygon, so I know that all the angles of the polygon is 144. So the sum of all my angles will be 144 times n. The sum of my interior angles is also expressed as n minus 2 times 180. So I'll use the same process. I will distribute the 180 here and here. Then I subtract 144 from both sides, and I add 360 to both sides. The reason I do that is because I like to have positive numbers. We could do this the other way. I could subtract 180 times n, and that would leave us with 36, a negative 36n on that side and a negative 360. The math will all work out to be the same when I divide by 36, negative 36, excuse me, leaves me with an n of 10 sides. Those are the different examples for our interior angle sums. We're now going to look at polygon exterior angle sum theorem. This theorem says that if I add up all of the exterior angles, one angle at each vertex, angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5, they will add to be 360 degrees. So essentially, that's saying that the sum of the measures of exterior angles of a convex polygon is 360 degrees. If I add up all of the exterior angles, I'll get 360 degrees. So we can see that with a couple of examples. We start with this example. I have 1, 2, 3, 4, 5 angles, so I will just add them up, starting at the top and working around. Let's try that again. 2x minus 5 plus 5x plus 2x plus 6x minus 5 plus 3x plus 10 is equal to 360 degrees. Now I use the process of combining like terms. I look at all of my x's. I've got one here, 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 here. If I add them all up, I got 18x. And I add up all of my 5, negative 5, positive 10. So that leaves me with 0. All of that is equal to 360 degrees. So this value is just 0. I divide both sides by 18. And I get an x value of 20. Now make sure that we're answering the correct question. It says find the value of x, so I do not have to go back. If it asked me to find the measure of each angle, I could take my x and plug this x value back in for each angle. Letter B is very similar. I'm going to add up all of my angles. I have 4 of them, starting from the top and working around. 6x plus 9x plus 2x plus 139 degrees is all equal to 360. Combining like terms, I have 17x plus 139 is equal to 360. I'm going to subtract 139 from both sides. That leaves me with 17x is equal to 221. Dividing both sides by 17, I get an x value of 13. Now I'm asked to find the measure of each exterior angle of a regular nonagon. Find the measure of each exterior angle of a regular, so I know that all the angles will be the same. A nonagon has 9 sides. So we're going to use a little bit of inductive reasoning here, and I have 360 degrees when I add up all of the exterior angles. So I know if I take 360 degrees and I divide it by the number of exterior angles, I'll get the number of, or the value of one angle. 360 degrees, so that's 360 degrees divided by 9, 40 degrees. So I know that if I draw a 9-sided figure, which would look like this, and I added up all the angles, one, 2, 3, 4, 5, 6, 7, 8, 9. I add up all 9 angles. Each angle will be 40 degrees. Make it blue so we can see a little better. Same process for the next question. Find the measure of each exterior angle of a regular dodecagon. We may have to look that up. I know that it's 12 sides. A dodecagon has 12 sides. So I will take 360 degrees divided by the number of sides. That's 360 degrees divided by 12, which gives me one side is 30 degrees. So now we can look at interior and exterior angles and figure out missing values, also using some algebra, some x's and y's. And that's it for section 6.1.